So Frank, I want to ask you more about photocatalysis because it's a field I'm interested in, and also many groups here in the department. So we are also discussing this before. So at which stage do you think we are? Do you think now it's going to fall down, or what do you think about it?
It's a question I ask you. So I think, no one really knows, but more and more is getting an advanced field. So you understand the mechanisms and you can more and more predict reactions. So I think there's also still many things that need to be discovered, and there will also be many serendipitous findings. But I also think it's fair to say that the field is now the right condition also for applications. Applications in biological systems. Today we also mentioned basically how molecules, catalysts are used in membrane systems.
Yeah.
But I think that's very rewarding to work with biologists in the field, but also material science. I think in material science also for chemical applications. I use partners with whom we work on photo switching, for example, and photocatalysis, of course, is also, I think, valuable in the context of materials. Something you could imagine to have basically the control of light to build up things, but maybe also with different wavelengths you can then basically have the catalyst basically catalyze different reaction. And I think applications will also kick in town.
And also, what about the level of knowledge about the mechanisms that we have now? So you think we are at the top level, or we can still know something, discover something new? Or
as you know, probably also many people in the field don't fully understand the mechanism. There are some players in the field that have a better level of understanding than others. And sometimes things might make sense on first sight, basically when you write in a paper, basically. But if you really are an expert, then you wonder, this can't be. About radical stability, radical polarity, lifetime of species, and then chain reactions, for example. Often this is not taken into consideration in many cases.
Yeah.
So I think in general there is already a lot of know-how, but not everyone has this high level. I guess you would agree.
I think majority is not at the top level. There are a few groups, but
And sometimes I think it's also true that in a catalytic cycle, often you can simplify. So even if the catalytic cycle is right, but maybe you just provide 3 different steps, there can also be additional steps in between, basically. So each step can also be more complicated. So you can say, for example, in cross-cutting, you can say this step is an oxidative addition, and you have a certain way of looking at it, a certain know-how, but you can also look at the detailed mechanism of the oxidative addition.
About data science, actually, it's something that I really wanted to ask you, because publishing your own data. So I'm afraid sometimes I think about this. So if people will start to publish wrong data. So let's say bad data, data that are not successful or something that is not working and so on. So, but I'm afraid that sometimes then young researchers will not look at it anymore, because this has been done, it's not working, but perhaps it was not working because some other reasons. So how do you think? So how we should act, what we should do in this sense?
So I think it starts with the wording. You could also see that one struggles with it. Wrong, unsuccessful, negative. I think as a community, we have not really defined the terminology to distinguish between different situations with you. And then to the core of your question, should one be influenced by negative data and basically then not consider reaction? I think it really depends on the specific case. How much you trust something, how much you believe in something. I think often, especially when you're a young professor, you probably have many ideas, and the idea might be right, but the way how it's executed might be wrong.
Yeah.
And a minor, I mean, sometimes it's just a minor detail. As I mentioned today, maybe the solvent makes a big difference. But sometimes it can be more things that are not done in a proper way that leads to failure. So I think you have to distinguish between the different scenarios. And I think sometimes when you strongly believe, you do many experiments and then it will work out.
Exactly.
But in a parallel universe, sometimes you will also try hard, and then it will not work out. And then one was lucky and the other one maybe not lucky, and then maybe this ends your career because you only had a couple of years maybe to make your name and things like that. I think sometimes you have to be lucky.
Yeah. And last question, like very broad question. So for young generation, so why why they should choose to become a chemist? What do you think?
Chemistry is everything. I think that's what we often fail to teach the students in the first years, because the first years we teach them so much stuff. And we say, oh, you have to learn this and that and name reactions and this, and we forget to tell them what you can do with the things basically after the study. I mean, the chemistry you can use to make medication, basically. I mean, agro science, and, material science, computers. There's so many things that you can improve with chemistry. And I think this fascination for the power of chemistry, we have to keep ourselves, and we also have to teach more and more to the students, because it is so fascinating. And I think sometimes it's also great when you basically do experiments for the general public, when you see that they are really fascinated by the color or the smell or the sound of experiments. So I think we are blessed that we can basically work in this field and do experiments. That's also something, I mean, the molecules I think are fantastic for me as molecular chemist, but also experiments are fantastic. The concept of an experiment and learning about how to properly run. I mean, students don't like to take notes and write down things. I mean, they just, but I think the whole thing is really fascinating. I mean, scientific process. I think also someone who studies chemistry, that's a PhD, is able to do jobs also outside chemistry. I think that's also very important to emphasize this. So the way of education, the way of development enables you to do many different things, logical thinking and problem solving.
Thanks.
Yeah, thank you very much.
Thanks. Thank you.